Friends, I am Shivam. Today we are going to discuss about Naïve classification in data science, exploring the principle and practical implementation of Naïve classification using R and Python for real-world applications. Naïve classification overview. First, definition of Naïve classification. Naïve classification is the probabilistics model used for categorical data based on Bayes theorem. Bayes theorem. The model operates on Bayes' theorem, which calculates the probability of a hypothesis given prior knowledge. Absorption of independence. Now Bayes assumes that the features are independent for each other, simplifying the conception of probability. Historical context. The model emerged in the 1960s has evolved into a fundamental technique in a machine learning. Applications in text classification. Nowise is widely used in text classification tasks such as spam detection and sentiment analysis. Advantages. The model is favored for simplicity, effectiveness, robustness, performance, and ease of implementation. Introduction to Naive-Bayes classifier. Naive-Bayes classifier are the family of probabilistic models used for classification tasks. They leverage Bayes' theorem, assuming independence among features to predict class membership. Gaussian Naive-Bayes. This model assumes that the features follow a normal distribution, making it suitable for continuous data. It is particularly effective when the data conforms to the Gaussian distribution. Multinomial Naive-Bayes, designed for discrete data. This model is commonly employed in the text classification task where the numbers of accuracies for each feature is a virtual factor. Bernoulli-Naive bias. Tolerated for binary or Boolean feature, this model is often used in scenarios involving text classification with binary term occurrence, emphasizing whether a term is present or absent. Flexibility of Naive-Bayes model. This model provides significant flexibility in handling various data types and structures, making them applicable across multiple domains such as finance, healthcare, and marketing. Advantages and disadvantages of the algorithm. Simple implementation. The algorithm is straightforward to implement, making it accessible for various applications. Less training data required. It can achieve reliable result with a similar amount of training data compared to more complex algorithms. Effective with high dimensional data. This algorithm perform when dealing with datasets that have a large number of features. Independence absorption. It operates under the assumption that all predictors are independent, which is limitation it may real-world scenarios. Feature independence violation. If the independence absorption is violated, the algorithm performance can degrade significantly. Sensitive to data preparation. The output of algorithm is highly sensitive to how the input data is processed and prepared. Data processing for neo-bias models. Key steps in effective model building. Cleaning data. This involves handling missing values effectively and remove any noise from the dataset, ensuring that the data is accurate and reliable for modeling. Feature selection. Identifying and select a relevant feature that contributes significantly to the predictive power of the naive-Bayes model, enhancing its performance. Normalization. Scale the data appropriate to ensure that all features contribute equally to the model's prediction, empowering overall accuracy. Load required library. To start using naive-Bayes in R, load the essential library with a command library. This library contains the function needed for the model. Load dataset. Utilize the built-in iris dataset by executing data iris. The dataset is commonly used for classification problems and contains three species of iris flowers. Train naive-Bayes model. Train the model using the command model naive-Bayes species. This command species the target variables species and in input features. Make predictions. Generate prediction with problems. prediction. This step applies the trained model to dataset to classify the species based on features. Output result. The To evaluate model performance, use table. This command creates a confusion matrix that compares predicted values against the actual species. Brief explanation. This code demonstrates how to train a neo-Bayes model using the iris dataset, make predictions, and display a confusion matrix for performance evaluation. Implementing neo-Bayes in Python. A step-by-step guide to qualification. Load dataset. Utilize the load iris function from a scalar dataset to import the iris dataset, which is commonly used for classification tasks. Split data. Implement the train test split method to divide the dataset into 70 training data and 30 testing data, ensuring effective model evaluation. Train model. Create an instance of the Gaussian neo-Bayes classifier Gaussian NB and feed it using training dataset to build the predictive model. Make prediction. Utilize the trained model to predict outcomes on the test dataset, enabling the evolution of modeling performance. Evaluate model. Generate a confusion matrix using confusion matrix to assess model accuracy and performance. Output the result for further analysis. Spam detection using neo-Bayes classifying. Classes use case. Spam detection is a traditional application for neo-Bayes classification showing its relevance in the real-world scenario. Email classification. The primary task involves categories email as spam and non-spam based on a specific word presence on patterns. Handling large data. Neovis is particularly effective in managing large volume of data, making it suitable for email filtering application. Quick predictions. This model provides rapid predictions, allowing for efficient real-time spam detection. High accuracy. By analyzing the frequency of spam indicative words, Neobias can achieve high accuracy in distinguishing spams from legitimate emails. Visualization Neobias model result. First, confusion matrix, ROC curves, features importance plot. Key takeaways from neighbors classification. Importance of data processing. Exceptions of feature independence. Applications in R and Python. Mastering neighbors for effective classification. Master neighbors classification. Join us to enhance your data analysis skill and apply predictive modeling effective in your project today. Thanks friends for watching this video.